Hey, all right, we're at the end of the chapter, and everything that we've been doing about lines and all that kind of good stuff, this is the last thing to talk about. There's also a thing called linear inequalities. And when you solve a linear inequality, basically, we're looking at one right here. It says the relationship is, it's not 3x minus 2y equals minus 6. It's less than or equal to minus 6. If we did equal minus 6, we'd get a line, because that's what we were learning to do. However, when we say less than or equal to, or greater than or equal to, or greater than or less than, we're not the line, but we're talking about, it turns out it ends up being one side of the line. So there's a whole ocean of ordered pairs on either one side of the line or the other that we're looking for, okay? So I'm just gonna show you the basics on how to do this, and I don't want this to get in the way. So let me show you the moves. Okay. So when I do this step one, what I do, if that says graph the solution set, or graph the set of solutions that satisfy this inequality, then, or it just says graph the linear inequality, then what I do in step one is I just go 3x minus 2y, and I set it equal to minus 6, because for me, this is the so-called borderline. This is where they're equal. If you're less than, you're one side or the other. So we got a graph to see where the dividing line is. Okay, let's do it. So the way I typically do it is I find a couple ordered pairs. You know what I like to do, I was showing this in a class, I like to plug in 0 for x, because when I plug in 0 for x, that term goes away. And then you just solve this, and you go, oh, well, if I divide by minus 2 over minus 6 over minus 2 is a positive 3. Likewise, I also do it for y. When it's in standard form like this, I like to do this, because when I plug in 0 for y, that guy disappears. Rewind, watch it again. When I plug in 0, that term disappears. And so when I imagine 3 dividing into minus 6, and what does that give us? It gives us a negative 2. Okay, so we've got ourselves 2 points that, that's plenty. I think some of the homework said graph it by finding the intercepts or something. That's what we just did. So 0 minus 3, 0 positive 3. Let's do this in another color. Let's go with this color, all right? And then minus 2, 0, there it is. And now I'm about to graph it, but there is one thing to consider. If it has to do with this symbol right there. Is it less than equal to? Is it greater than equal to? In other words, is it equal to, or is it just strictly greater than? And here's a little map for you guys to understand. If the problem comes at you as less than or greater than, you know how we put an open circle if we were graphing on a number line? Well, now we're in 2 dimensions. We have to go to the dotted line. That's a line's equivalent of an open circle. And if it's greater than or equal to, less than or equal to, then you can use a solid line. What are we going to do in this problem? There it is, solid line. There you go. All right. Okay, so this is the borderline. You keep pushing my love over the borderline. Madonna fans? No? Anyone? Okay, good. The next step, 2, I'm going crazy. 2 is flip a coin. We got to figure out which side to graph, or to shade, I should say. So this is where people go, okay, I don't get it, I don't get it. Okay, so what I do is I just pick a point and I test it. It's like an ambassador for that side. So if I picked a point over here on this side of the line and it works, if it's true, what's true? If I plug it into the inequality and it makes the inequality true, then we get to shade that side. However, if it doesn't work, if it's false, we shade the other side. So I guess what students have told me in the past is they go, we have to shade the true side. All right, so take down your inequality, 3x minus 2y less than or equal to minus 6, and let's try a point from somewhere. And what we said in class, a good point to use is this guy. He's easy. 0, 0 is always a good test point, unless the line goes through it. Then you actually have to jump off that point to some other point, but typically this is a good one to test, okay? All you have to do is plug in 0, 0 into your inequality to see if it works or not. Okay, so we have 3 times 0 minus 2 times 0. And all of that's so easy, it's just 0. I don't have to compute a number or anything. I just find out that it's 0. And the question is it less than or equal to minus 6? Okay, here you go. True or false? 0 is less than or equal to minus 6. I know, huh? Here's a number line. Here's 0. Here's, oh yeah. 0 is actually bigger than minus 6, huh? So this is actually a case of being false. It's false, okay? So what does that mean to us? That means that with the side where 0, 0 came from is the false side. So where's the true side? The other side. That's the true side. We always shade the true side. So the last thing we do is we take out whatever marker you want and we start shading that side and we tell the world in my math lab, there you go. And that's the answer. And that's how it's done, folks. I hope that makes sense to you. Some people have trouble with the testing, and you can see how this is done in a short video. Good luck on that stuff. I'll see you at the next video.